Hello. Today we're going to talk about using input-output tables to determine if it's linear or quadratic using first and second differences. So what you need is your textbook page, Module 3, page 173. Cut out this part, the graph and the tables. Cut it out. Yours is going to be green or some other blue color. Anyway, so what we're going to do, they already gave us the input-output table. First differences means, what's the difference between these two? If we're going from 7 to 6, that's minus 1. From 6 to 5, that's also minus 1. I'm minus 1. Minus 1, minus 1, minus 1. So this equation right here, if it only has first differences and you don't have to go here, it's linear. Let's check it out. Let's graph it. So, -3, 7, -3, 7, -2, 6, -2, 6, -1, 5, 0, 4, 1, 3, 2, 2, 3, 1. That is a linear equation. All right, let's check out the other one. Here, if we're going from -5 to 0, we're actually adding 5. From 0 to 3, we're adding 3. 3 to 4, adding 1. 4 to 3, we're subtracting 1. Subtracting 3. And from 0 to -5, we're going down by 5. They're not the same numbers. If they're not the same, go to the next. When you go from 5 to 3, you are subtracting 2. When you're going from 3 to 1, subtracting 2. From +1 to -1, you have to subtract 2. Subtract 2 and subtract 2. When your second differences are all the same, you have a quadratic. So let's graph it. -3, -5, -3, -5, -2, 0. That's one of our solutions right there. -1, 3, -1, 3, 0, 4. That's our y-intercept. Also our vertex, because look, it's going right back down. 1, 3, 2, 0, our other solution, and 3, -5. Once you've done this, I want you to practice a little bit from the workbook. Distinguishing between the two, how you can use an input-output table to determine if it's quadratic. If you have to go to second differences, look at second differences, you got power of 2. First differences, invisible power of 1. Can you see it? Okay, that's it. Let's do the next note.